Let's suppose we have this function. This point, the function exists on both sides. It's a maximum because I can show the open interval left and right, the function exists. So this is a relative max. It happens that is for this function, it happens that is the absolute max as well. Now you could say definitely that this is an absolute min. Would you agree? Okay. But I cannot show the open interval left and right because the function does not exist on the right-hand side, and I will say this is not a relative min. For a relative, I have to show the function on both sides. Also here, what does this mean? Nothing. It's not an absolute max, it's not an absolute min, and it's not a relative because it's at the endpoint of the interval.
I thought it was absolute if it was at the endpoint.
But it's not the absolute. There are other values higher, and there are other values lower. So it's not absolute. Absolute meaning the top and the bottom possible. It's not. It's somewhere in the middle. This is the absolute max, and this is the absolute min. I cannot have more than one absolute max and one absolute min.
Okay.
Is it my pleasure? Chloe, is that clear?
But a relative could.
The relative, I can have millions.
Oh, yeah, because it's all throughout the chart. It's just not.
All throughout the function. Yeah. Yes. But for the absolute max, only one. If it's absolute, it's one. If it's absolute min, it's only one. Very good. Okay, so let's look at let's say 66 from the other section on page 242. And we have f of x equals x plus 3600 divided by x. 66, yes. Sometimes I copy from a different problem. So in this case, the interval is given as an open interval, 0 to infinity. All I have to do is find f prime, which is 1 minus 3600 over x squared. So let me refresh our memory. If you could remember this, it will really help us. We discussed that, right? Because 1 over x is x to negative 1. You bring down negative 1, you subtract 1 from the power, you end up with x. So when I differentiate x, I get 1. 3600 stays outside. 1 over x prime is negative 1 over x squared. Is this okay? Please ask. So then f prime of x, I have to find the least common denominator, which is x squared. So x squared minus 3600. I set this equal to 0. To find what? Critical numbers first. But the question is, can this be undefined where the function is defined? No. This is undefined at 0, but so is the function. So only from one source. When is a fraction 0? Very good. So x squared minus 3600 equals 0. Well, I know how to factor this. How do I factor it? To find the two options. X minus 60 and x plus 60. So there are two options. Let's create the table now. F prime and f of x, 0 to infinity. We are given an open interval now. So since it's 0 to infinity and the two values are x equals 60 and x equals negative 60, I cannot put negative 60 in the table. But I can put 60 and 0 as a critical number. I do have to find the function value here because I am asked. So I have to plug in the function 60. Let's plug in the function together. 3600 divided by 60 must be And 60 plus 60 is?
120.
That's it. Now, can you say that this is a max, an absolute max or an absolute min? No, because we have not studied the sign of the derivative. There is no absolute max or absolute min at infinities. If I say this is the absolute max or absolute min, I have to give you the both coordinates. At infinity, I cannot give you a coordinate for the y value. So now let's go back to this, the first derivative. So should we plug in the denominator anything? No, because it's always positive. So I'm only going to plug in here. So let's plug in 0 to see on this side. When you plug in 0, what sign does that have? Good. So now let's plug in 100. 100 squared, will it cover 3600? Yes, 100 will have 4 zeros. 10,000 minus this will be positive, correct? What is this typical of? Absolute min or absolute max?
Min.
Very good. So absolute min at 60, y equals 120. So the point is 60, 120, and this is the absolute min. There is no absolute max. Why? I cannot plug in 0 in the function. It's undefined. And I cannot plug infinity. Nobody cares about infinity. Please, any question?
About getting the derivative of the x plus 36 over x, I understand when we were talking about the 1 minus 3600 over x squared. Where did the other x squared come from? At the bottom.
So positive 3600 over x is like 3600 times 1 over x. The constant stays outside. But when I differentiate 1 over x, I get negative 1 over x squared.
Gotcha.
Remember, it's x to negative 1, negative 1, negative 1 minus 1, negative 2.
Right. And then when we go down to our derivative, it's x squared over x squared.
Right, because 1 has to change into x squared over x squared to add them. I cannot add fractions without the same denominator.
Okay.
So this has to be x squared over x squared, so I can write x squared minus 3600 over x squared.
Okay.
That's how we add fractions, right? I need the least common denominator, and the least common denominator is x squared, so I have to multiply that by x squared.
Okay, that's where I was confused.
Better?
Yeah.
Perfect. Good. So let's work on a word problem here. What about maximizing profit? 102. Any questions? Angel, you want to say something?
I said the American dream.
Okay, good. 243. Cornerstone Electronics determines that its weekly profit in dollars from the production and sale of X amplifiers is P of X equals 1500 divided by X squared minus 6X plus 10. Find the number of amplifiers X for which the total weekly profit is a maximum. So find X for max P of X. What do I have to find? And obviously, when we talk about amplifiers, we will say that X will have what domain? Well, impossible, but we're not given a limit. So I will consider 0 to infinity. Good. So what do I have to find in order to tell the production manager, listen, if you manufacture blah number and you sell it, because if you put it on the shelf, it's not going to do anything. So you manufacture them and you sell them for maximum profit. What will you find?
Absolute max.
Yes, I have to find the absolute max. What is my first step?
Derivative.
Perfect. P prime of X. I will prep my function first. I will change this function into, what do you think I'm going to change it into? Now you know me.
The final. Here, change everything at the bottom to a fraction.
1500 times x squared minus 6x plus 10 to the, that will be the square root,
Negative
negative,
1/2.
negative,
2/1.
negative.
2.
So x to negative 2 is 1 over x squared, but that's not what I have.
-1.
Exactly.
Okay.
You can say why. Because I don't want to differentiate a quotient when the numerator is 1500. When it can stay outside, it's a constant. So now I bring down 1, negative 1500. I subtract 1 from the power times, I'm going to write it here, times what? This is separate.
The inside.
The inner function prime, which is 2x minus 6. Maybe I should write it one more time. P prime of x, negative 1500, x squared minus 6x plus 10 raised to negative 2 times 2x minus 6. This is the first derivative. What do I do to it now?
You set it equal to 0.
Correct. So let me clean it up a little bit. P prime of x equals negative 1500. I will factor out the 2 times x minus 3 over x squared minus 6x plus 10 squared. So you can say now you went back. Yes, because now I'm trying to solve this equation. I'm going to set this equal to 0.
Why was our 1500 negative now?
Because I brought down negative 1. I brought down power negative 1. 1500 wasn't negative, but I brought down negative 1. So when P prime is 0, how much is x? And there is only one answer. X is?
150.
X is?
0.
We hope not. We hope not. We're not going to tell the production manager you're going to have maximum profit if you don't do anything. When is this fraction 0?
1 million.
Which is?
Negative
3. But now
3.
we assume that this is in thousands or something. It says from the production, well, no, it's not. So it's just 3. 3 units.
That's what it's maximum. What does he say?
Oh, I don't know yet. I don't know the sign yet. I haven't studied that yet. This is what for the function? Oh, that's it. That's all we know. That's all we know for now. So this is 0 to infinity, and this is P prime, and this is P of x. And we found 3. Okay? We're not asked to find this number, but we can. 1500 divided by, what is that number? 1500 divided by, what is 3? So that's 9 minus what? 18 and plus 10. 1500, okay. So we are telling the manufacturer, the production manager, if you manufacture 3 amplifiers, I don't know what type of amplifiers they are, you will get your profit to be 1500. But now we have to tell him and show him why this is possible. I don't know, maybe it's the minimum. How do I know? I don't know yet. So I have to go back to the original function, to the derivative, and I will refuse to plug in anything in this portion. Why I refuse to plug in anything in that portion?
It's hard to find.
They're all positive. 1500, 3, 2, and all this is positive. I'm not going to waste my time. So I'm going to plug in 1 in here, keeping in mind there is a negative, and I want a sign.
-2. Negative.
Careful. So if I plug in 1, this becomes negative. With this negative, this is positive. And now I'm going to plug in 10. 10 is here. 10 minus 3, but negative. So now you're going to say to the production manager, I guarantee you, sir or ma'am, that if you manufacture 3, your maximum profit will be 1,500. Why? Because it means this. And he will say, but you know what, I want an even more bigger profit, I want to manufacture 1,600. What would you say? It's not going to work. If you manufacture 1,600, your profit would be lower than 1,500.
So is that
If you manufacture 10, your profit would be lower than 1,500.
Is that the absolute? Or?
The absolute.
Okay.
Absolute. It's increasing from 0 to 3 and will be forever decreasing past that. So it must be an absolute. So what is left for next week before the spring break? We're going to continue. This is the same thing. The next section 2.5 is identical with what we did today, just more applications. And then marginals and differentials. We did not do in this class the elasticity of demand, but we do implicit differentiation. So I'm hoping that we can finish this chapter next week so we can review after the spring break. So you have the entire chapter done. We'll see. If you have any questions, please stay. Thank you for being patient. If